All right. So what have we got going here? We were talking about Richard Guy's recent passing and the subsequent death of John Conway. John Conway is probably most famous for the game of life, which is in the area of automata theory. And damn, we could go down another rabbit hole there. So many rabbit holes, so little time. Um, well, and then there's Nim. Uh, now, okay, let's make another sidebar over here. Conway's game of life. Should we maybe look to see if there's a little applet for that? Bitstorm.org is the first one that comes up. I'm not going to complain. Okay, so here is an initial position. Now, so what you have is a grid of cells, right? And the rules for generation are if a cell has 2 or 3 neighbors, then it stays alive. If it has fewer than 2 or 3 or more than 3, then it dies. So this cell, for instance, whoop, I turned that on, didn't I? This cell will die because it's only got one. There are 8 neighbors potentially, right? I think I'm saying the rules right. Oh, what's this? Oh, this is the figure from the Rest in Peace. Oh, look, that's going to give you a. So this is Rest in Peace John Conway from XKCD. Yeah. I don't know. No, I don't. In any case, so what? So this one will be born. Can we just do next? Okay. Right. So you can see that this one was born because say. All right. I didn't say if it has. I think 3 neighbors, then it's born. So 2 or 3. You survive. 3. So an unborn cell with 3 living neighbors will be born. So like, watch this cell right here. It's going to be born, right? Yeah. This cell will then be born, right? So which cells are going to die? Well, this one here will die because it's only got 1 neighbor, right? But this one here will survive. These 3 will survive. Well, these 4, 5, yeah, all of these guys will survive except for the 2 on the end, right? And then some other ones are born, right? So that's there's no plane of the game. It just evolves on its own, right? So it's not the kind of game you play. It's you just watch it and see. Now what's going on here? Okay, so this is when John Conway thought of this game, I think 1972 or something. He couldn't decide a few questions. One was, can you have eternal life, or can it grow without bound? And can we? I know I'm way off on the tangent, aren't I? Guys, streamer life. Am I? Oh, no, that's probably a bad search, huh? John Conway, Richard Guy, streamer. Is that going to get me there? Okay, you can see these. Well, how about this one? Oh, so this is a book for sale, huh? There's another book for sale. Here's a magazine article. Richard Guy. So can we talk about life? Early life, later life, and death. Okay, so lifelong interest, later life and death. Okay, Conway's game of life. So yeah, what does he say here? Guy conducted extensive research on Conway's game of life, and in 1970 found the game's glider. Right there it is. Right, gliding along. Can you see it there? It's a little obscured by me. Can I move me out of the way here a little bit? Okay. Yeah. And there's a three-dimensional version of it here, so you can kind of see the trail of forms it leaves behind. In any case, I think that's what we're seeing here, right? Can we just okay, yeah, you see that it's streaming along. I think you can also sort of create these in a streaming factory, so it keeps shooting out more and more streamers ad infinitum. Okay, and then so there's this article he's writing about. We never did figure out what the NIM is here, but just to give you an idea of how prolific this guy is. 103. Turns out this article, and it just goes. Look how long this thing is. Oh my God! And it's just full of triangles. We're not even halfway down here, and pretty crazy stuff. This is freely available. I'll tell you what. I'll put the link to this if you're interested in some summer research. This could be the basis for your PhD. Who knows? I will post it here in the discussion. Or we haven't finished our agenda. Okay, let's get on with the agenda, shall we? So, let's see. Chapter 17. And let's try to make some time for the Nbody. Anything else you'd like on the agenda? All right. I think we've already covered number 1. So let's go on to number 2, which was we were kind of doing the drill, I think, when we left off, right? Oh, I think we had started working on some steganography as well, or yeah. Okay. Yeah, and what can I say? I haven't written that up. I did. Oh, let's talk about the midterm. Okay, we can put that on the agenda here. Since I do have something for you there, but I haven't posted it yet. So let me show you how that works. Okay, so this is going to be midterm part 1, and it's a little slow going and generating these things. I'm finding the rope, so it should start going faster, but yeah, it hasn't been as productive as you might hope, or maybe you wouldn't hope. It's okay. So let's go to assignments. All right, and I need to add a new assignment. And this is going to be midterm part 1. And let's say it's, I don't know, it's only part 1. So let's make it 20. Maybe there'll be 4 parts. Yeah? All right. And it's going to be an external tool. We're going to use 7B Open Math, I think. That ought to work, huh? I think that ought to get me in there. What about, I want to choose something. Oh, crap. This placement on your LMS has not yet been linked to content on My Open Math. All right. Why? Maybe, maybe, yeah, see, I have different ones here, don't I? Okay, okay, there it is. All right, midterm, so make placement, select, all right, and 25, save and publish. Um, okay, so this first one is a matching problem. Okay, so what you do is click on this thing and choose the letter or the word that you think is being defined in that phrase. And, I think it's vocabulary is important. If you don't know what the words mean, then what are you talking about? Yeah, people use all kinds of words, but a word is just an abstraction. It needs a definition. So I used to ask students to, define these words, and I just leave an open space. And if the word is like ixcabibble, then the student will say, an ixcabibble is what you get when you have an ixcabibble. Sort of self-referential, recursive definition, if you like. But not particularly enlightening or illuminating. So I think it's better to do it this way. And there are 12 different words here, so you get plenty of. I think it's a one-to-one correspondence. All right. So if we say continue, we get the second problem. This is a fill-in. Now, so this one you're going to enter in text, right? So I'm going to say describe the variable type for PC. That's this variable here, right? So I'm going to say that's a character. Okay. And then how is, or I could write out the whole word character, right? And I'm going to say how is the variable, it's set to 0, right? And describe the variable type for RC. Well, RC is also a character. Yeah, that's what it is. And how is the variable initialized? Well, it's set to PC. Yeah. And this is division by 0. So if I submit that, oh, I can't submit it. I can just say continue. Oh, look, I got them all wrong. Yeah. So those are, I gave you some wrong answers, but that's the idea. Now what I have to do is I have to make sort of a regex thing, and I don't think I put in any capital letters at all, and I didn't put in, it was a bit of a time crunch at the end, and I didn't put in a thing that would say, if you capitalize something, just ignore the capitals. So don't capitalize anything on that last one. I don't know, what can I say? Or maybe I can change it so that there is a little variable you can set so it'll ignore capitals. All right, so then here's a program, and here's some questions about that program. These are mostly multiple choice. I think there's a few fill in the numbers, okay? And that's it. There's just these, well, I mean, there are many parts, right? So you're going to want to understand this program and I think you have till May 6th, like a week. So we'll try to roll out these problems steadily here as we go. And I'll try to cover the waterfront. I don't know what I covered here. There's some pointers and memory and the vector class and how it works. Okay, which is what we're going to talk about in chapter 17. But there it is. So you should be able to find that now on your here. So if I go to assignments, we see now midterm part 1 is there, and it's published. So have fun. All right, so let's get back to the discussion, and that takes us to here. And today's did I not? Oh crap, I hate it when I do that. I didn't save the agenda. No problem. I mean, not a big problem. Agenda for 42920. And it was, well, we had our little John Conway. John Conway's most recent big accomplishment, by the way, was his proof of the free will theorem. Now, the free will theorem doesn't prove that there is free will, but it says something crazy like, if there is free will, then particles have to have them, like subatomic particles, even, I think. I may be stretching it, right? But like an electron will have free will. If there is such a thing as free will, then it must extend to tiny little particles. I love that. Yeah, everybody's on their own. Go out there and mix it up. Choose what you like. Okay, so this was a little memoriam, and we had, I think a link here, which we wanted to share. Let's see, is there also something for Conway? Yeah, let me grab that as well. His little lecture on free will, if you like, is worth a little examination. Yeah. Okay. So this is the free will one. Okay. Oh, I don't know why. Why did YouTube creep in there? That was weird. Like a little. Huh. Wow. How weird, huh? It's like it's a transparent background or something. Weird. Huh. Or maybe, yeah, it's just that it's a YouTube video, and so they want to have their little logo in the background. I've never seen that. Okay. And what was the second thing? Oh, yeah. Chapter 17, and then maybe some Nbody stuff. All right. Did I misspell memoriam? Memorize and emporium. No, there's memoriam is a word. Shall I? Canvas is kind of dumb. Have you noticed that? Oh, there's memorial. There is no word memoriam. I made it up. How about memorial? There. Okay, I take it back about Canvas. So my arbiter of truth there is the OED. If I can't find it in the OED, then maybe it's not really a thing. Okay. So maybe we should say 18. Yeah, let's get started on chapter 18 too, because, well, I don't know if there's time. So with that, now I'm going to post the reply so we don't lose it. Oh, I see. So there's the little pic that they put together, and we can watch it right here. Huh? I know you don't hear that, do you? Do you hear that? I'm a little curious about. No, yeah, okay, right. It's in my headphones, which you know, the old adage about you should be made to wear headphones. So it goes. But yeah, I need to figure out if I want to broadcast audio. I mean, if you hit that link you'll hear it, right? But if I want to broadcast audio, I need to set up my OBS to handle that. And let's not fuss with that now. Okay. This you can ignore this guy. Just skip past him. How long does it take to get? Okay. And then you get to see Conway. And there's a recent biography of Conway, which you can also find him discussing that with the author on YouTube. All right. So moving on. Here we are in chapter 17. Oh, and I wanted to get the right code for that, right? So I think it was here. Let's get rid of this. Exclude from the, yeah, sure, save that. And I'm going to say add existing item, because I think we had started one, right? So PPP17 drill, there it is. And we had gotten through 10. Looks like it. And so if we go back to the book, we see allocate an array of 10 ints and assign the address to a variable. Oh, I don't know if I did this one. Allocate an array of 10 ints, initialize it to 1, 2, 4, 8, etc. I guess following powers of 2, and assign its address to a variable P1. I don't see P1 here, so let's go ahead and... Oh, sorry, this is the other part of the drill. Yeah, there were two parts of the drill. And we did this one, right? Okay, so here's the second part of the drill. So should we say this is drill part 2? I'm going to say, yeah, let's open up another. So I'm going to say Solution Explorer, add new item. So this is going to be PPP 17-drill02. And I've got the other one sitting here still, so let's grab what we like from there and leave the rest. I don't know if I like all this, but at least the stuff at the top. And then let's put the statement of the problem here. Put my name at the top just to set a good example. And the second part of the drill focuses on pointers and their relation to arrays using print array from the last drill. Okay, do we have that? Yeah, there it is. Allocate an int, initialize it to 7, and assign its address to a variable P1. Okay, that seems fairly trivial, doesn't it? So, but when they say allocate an int, they mean on the free store, right? I'm pretty sure that's what's meant there, right? So I guess we'll just get rid of this stuff. And so I'm going to say int P1 equals new int. Oh, sorry, pointer to int, right? There we go. Oh, sorry, you're not looking at the code. Here we go. Right, so and when we read that, we kind of want to read it from right to left, right? So what kind of variable is it? It's an int. Well, it's actually a pointer to int, right? But so what kind of memory are we allocating? We're allocating memory for an int, so it comes in 4-byte chunks, right? And where are we allocating it? On the free store, right? So or the heap, if you like. And that's done with the keyword new. And so we're assigning the address of this allocated memory to the variable p1, which is a pointer to an int. That is, it's a variable that contains the address of an int. Okay, so then I'm going to print out, it says here, I'm just going to copy this over without, so print out the value of p1 and of the int it points to. Great. Okay, so I'm going to say cout p1. Now this is going to be a memory address, right? And then if we want to dereference it, we can get the thing that it points to. P1 points to that, and then we dereference it, so we get that, and then if we compile and run that, we get a nice, oh, we got too many cooks in the barn. So let's get rid of the first one. Okay. And what do we see? Is that a memory address? Well, yeah. Right here, huh? How many bytes is that? Well, each hexadecimal digit is 16, has 16 possible different values, 0 through F, right? And a pair of hexadecimal digits then comprises a byte, right? 16 times 16 is 256. That's the number of possible values of an 8-bit number. And so we've got 1, 2, 3, 4 bytes. 4 bytes, huh? That's 32 bits. So why am I getting a 32-bit memory address when my machine is a 64-bit machine? I don't know. I'll tell you what, I'll go to, I don't know if I can share this, so I will, system information. I go to the Windows button and press system information. You're not seeing this, so let me make a copy of it, but can make a copy of what? Well, it's a x64 based PC, it says, right? And I should be more fluent with this stuff here. It's telling me that the available virtual memory is 5 gigabytes. Installed physical memory is 16 gigabytes. Total virtual memory is 38 gigabytes. Page file space. Yeah, this, if you run out of that, it starts allocating memory on the disk. But yeah, I guess, you know, we just know it's a 64-bit machine somehow. Okay, so the hardware resources, memory, and I guess I can't. I can't copy these things. I was going to copy and paste them. All right, so I'm not going to talk about stuff you can't see, but you can do the same thing on your computer, right? Go down to System and look at how your memory is laid out, and you probably have a 64-bit machine. Most machines these days are, right? And okay, I'm going to just leave this. So why, if I have a 64-bit machine, then why is it showing me a 32-bit address? And then why is this a garbage value here? Well, I never initialized it, right? I didn't set P1. I didn't put anything there, so it's whatever garbage is there. Notice that the compiler is perfectly happy to do that. And so let's just move on. Oh, here. right? What if I wanted to put something there? Well, I could initialize it here, right? Then if I were to run this, I could get yeah, the contents of that memory address is now 17. I never answered the question as to why on a 64-bit machine do I see 32-bit values? And I suppose we could go to the browser and ask the browser that question, right? This, by the way, you can draw stuff here and see what happens, right? You can spell your name and see how that evolves. Can I just make it go without? It's very fussy, isn't it? Start? Okay, yeah, so then it just sort of evolves. Did I go off on the tangent? Oh my goodness. So yeah, you get blinkers. There's a blinker. Yeah, endless fascination with there's a whole branch of computer science related to automata theory. So my question was, why? Can you ask why? Visual Studio shows 32-bit on 64-bit. I don't know. Is that going to get it? Visual Studio 64-bit? Question mark. Is there any 64 Visual Studio? Why not? Here's an answer which is approved by 237 pieces for numerous reasons. No. So why is explained in this post, and then there's going to explain it further here. First, from a performance perspective, the pointers get larger, so data structures get larger, and the processor cache stays the same size. That basically results in a raw speed hit. Your mileage may vary. So you start in a hole and you have to dig yourself out of that hole by using extra memory above 4 gigs to your advantage. In Visual Studio, this can happen in some large solutions, but I think the preferable thing to do is just to use less memory in the first place. Many Visual Studio's algorithms are amenable to this. And there's more story, but so yeah. So Visual Studio is throttling us back to 32-bit addresses. So that's why. It's not using the full power of your machine. Okay, so moving on. Yeah. So 3, allocate an array of 7 ints. Okay, I'm going to just paste this here so we can read it together. So this is 3. Allocate an array of 7 ints. Initialize it to powers of 2. Okay. So now, so this is going to be 3, huh? P7, how about that? Equals new, and now we have to say int array, right? And I'm going to initialize it with an initializer like so. 1, 2, 4, 8, 16, 32, 64. Is that 7? That's 7, right? Okay, I think that does what was asked so far. Now what else? And assign its address to a variable P7, whatever, and then print out the value of P7 and the array it points to. I'll change that to a 7. Okay, so can I just change this. Oh, I think I just want the array it points to. So P7, 7, and so I think I've got this print array, right? And A is, and so, okay, so we're going to say print. Can I just call this print array? I don't know why it's print array 10. Alright, so I'm going to call it this way, print array, and I need to give it P7. I need to give it, oh, first CN, right? That's the output stream, or cout, right? And then I think there are 7 values, so let's see if that doesn't work then. Oh, it got an error. Array size must be specified in new expressions. Oh, yeah. Back to the code. Right. So I didn't specify the array size, did I? Right here. Even though I did initialize it, shouldn't that specify the size? Alright, let's just put a 7 there. Compile. And our output looks like just what you'd expect. Now notice that this address is pretty close to that address, right? And this is the compiler allocating memory on the free store. Now which one is bigger? The second one is bigger, huh? Goes 152F and this is 152D. Why? It's mysteries of the compiler. Okay. Yeah, I don't see any obvious reason why this. So what's the distance between these, right? Can we do the subtraction? Well, taking 116 away from 2 16s, we got 16 minus 8 is 8. Then 1 minus E. Well, E is 13. No, 14. So it's going to be 116 plus 1. Well, 16. So we say, so I'm going to take, so I got 17 minus 14 is 3, huh? So what have we got so far? 3, 8. And then we borrowed, so that's going to be a 0. So yeah, 3, 8, meaning 3 16s and 1 8, which is 56 bytes apart. Why? I don't know. Certainly we don't need all those, but I guess they put a little space in between them, or maybe there was something already there. You, of course, on your machine will get different results, right? Okay. At least so I would expect. It would be a coinky-dinky if we got the same result. So declare, I'm looking at the next number 5 here. Pointer to an int called P3 and initialize it to P2. Okay. So I guess so I got a pointer P3. I'm going to initialize it to P7. Assign P1 to P2. So that's assigning P1 to P7. So P7 is equal to P1. So what's that going to do? Well, we didn't lose P7, right? Because we saved it in P3. But now we're overwriting P7 with P1. Did we lose some memory in that process? Oh, yep, sorry. Appreciate that. So the assignment step here was to assign P1 to P2, or P7 actually, right? And this is also P7, isn't it? Don't ask me why. Okay, so but P1 is going to write over P7, but we haven't lost that memory because it's now being pointed to by P3. Okay, yeah, and that's a new variable. Okay, I think that's okay. And then it says assign P3 to P7. All right, so it's 3-card Monty here. Assign P3 to P7. Wait, P7 to P1. Oh, I got that the wrong way about, didn't I? Okay, well, I have to rethink that. Okay, so, all right. So we assign P7 to P3. Wait. So declare an int called P3 and initialize it to P2. That's this, right? So that's a new one. So it's just a copy of P7. Does it remember that it's pointing out? P7 is an array, right? Does it remember that it's pointing to an array? And then what if P7, which points to an array, is then assigned to P1, which points to a single int? Do we lose that? So that's sort of the question that's at work here, huh? And then the last one here, I don't think I've done this yet, assign P3 to P7. I'm kind of at a loss as to why you would do that. Wait. I'm sorry. Assign P1 to P7. Oh, yeah, I had it right before. Sorry. And then it says assign P3 to P7. All right. I'm just following instructions here. Then print out the values of P1 and P2 and what they refer to. P7. And what they refer to. Okay, so P1, so see out P1 equals P1 inline, and P7 equals P7 inline. And I don't know, do we need to, are any of these things arrays anymore? P7 was an array, right? And we printed that out, and then we assigned it to P3, and then we assigned P1 to P7, and then P3, which was a backup of P7, we assigned back to P7. So it's like we did a little shuffle, right? Did we lose what P7 is in the process? So I think that's the open question here, huh? All right, well, let's find out, right? Oh, P1 and P7. So what P1, see out P1 equals, what should it be? Just what it P1 was never been assigned to, right? So it should be exactly what it was, which was 17, I think. The question is P. Okay, so here we go. F7, and what do we see? Yep, P1 is unchanged as we expected. And P7 is back to being what it was, right? P1 was an address. Okay, so these are now only 3-byte values, right? This one is at, yeah, and then this one is also, so P7 has the same address that it started with, which makes sense because we make a backup of it, we overwrote it, and then we made a backup. So it's the idea is that these things are memoryless, right? They don't know how big they are, they just know where they point to, and if you allocated integer type memory to a block of memory, then, you know, if you start at that address, then you got integers there, it'll print them out. Okay, then deallocate the memory you allocated from the free store, and well, let me just copy the rest of these. So this is starting with number 9. Deallocate all the memory you allocated in the free store. All right, let's do that. So this is delete P1, I believe. Delete the array associated with P7, and delete, I think P3 is also an array. And then allocate an array of 10 ints, initialize it to the same thing, powers of 2, and assign its address to a variable P1. Okay, so we freed up P1, right? So it's available now for a new assignment. And so this is going to be an array of 10 ints. And they're going to be 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and I think that's 10 already, isn't it? Here's the first 5. Yeah, there's 10. All right. And allocate an array of 10 ints and assign its address to the variable P2. So P2 hasn't been, oh, that's our old P7. Okay. And so P7 equals new int of 10. So this is uninitialized. Copy the values from the array pointed to by P1 to the array pointed to by P7. Okay. So there is a copy function which takes addresses, right? So I'm going to take the address P1, the address P1 plus 10. Now this is pointer arithmetic. So when I say P1 plus 10, I'm saying 10 integer chunks down the road, which is going to be 40 bytes, right? So the block of memory from P1 up to, but not including 40 bytes down the road, that chunk of memory, copy it to the memory that starts at P7. and we should be able to check that that's what it should be with a print array. So let's go ahead and, I noticed I needed to make a new line here. So and I want to actually print out 10 values. So how about a copy of P7? Just so we can see that. Okay, now does this compile? And no, it doesn't. P1 redefinition, multiple initialization, same thing for P7, so it doesn't like that. So while we deallocated it, we can't redefine it, right? So, but we can do this. So so I'm sort of declaring it like we're a new variable, right? And it's not a new variable, but we can allocate new memory for it. So let's try that. Yeah, that, oh, we got an exception here. Has triggered a breakpoint. Oh, really? Well, maybe it's because I'm doing this funky copy thing, huh? It doesn't like this. Do I need to include the algorithm library or something funky like that? I'm not including. Oh yeah, I've got numeric. I don't think I need algorithm for copy. I think copy is one of those things that are just sort of available. It's funny, it did sort of run a little bit. Did we look at the output window at all? Oh, there is something in the output window. Let's take a look at what's there. Okay, so we see we don't see the copy business, right? So it's just up to the new stuff, right? But then when it gets to the new stuff, it kind of freaks out a little bit. So it doesn't print this out. So it doesn't successfully do this copy thing. Okay, no problem. There are a couple of ways we can do. We can use the subscript operator, right? So we can say for int I equals 0, I less than 10, increment I, and then say P1, sorry, P7 of I equals P1 of I. And then, oh, I was doing it the wrong way about, wasn't I? Yeah. Oh no, I was copy from here to there, right? And this is doing this a copy from here to there. Oh, we're still getting that exception. Yeah, we're getting the same output we had before. Seven equals new int of 10, right? And then we copy from P1 into P7, and then we print array of P. Oh, we want to print array P7, not P1. Although P1 should be fine, right? It should have 10 elements. There's no reason why that shouldn't work. Maybe I think here I have a problem right here, don't I? What is so we assign P3 to P7, right? So P3 and P7 are pointing to the same place. So if I delete it twice, which is what I'm doing here, that is once too much. Yeah, that's a weird kind of memory error when you delete non-existent or delete memory that is no longer allocated. Yeah, so I forget what exact exceptions were being thrown there, but I think let's try doing it this way again and see if that doesn't help. Okay, that is better. So here's the output window now. So yeah, so now it's saying a copy of P7 is here, and let that be a lesson to you. We were trying to delete the same thing twice, and wasn't obvious what the problem was until I went back and considered what I was doing. Yeah, be careful when you're dealing with memory. You become responsible in ways that you may be unaccustomed to. All right. Now, just to be sure, whoops, what happened there? Oh, I kind of maximized my window. Oh dear. Okay, it went away. Good. All right, so now we could also, in addition to this is sort of an elegant little copy routine here, right? But we could also do it this way, just to demonstrate. Okay, so F5, yeah, we get the same output. And there's one other way we could do this, which is instead of using the subscript operator, we could say the contents of P7. So here I'm using oh, this is the contents. That's supposed to be a dereference operator. So the contents of that memory location are going to be assigned to the contents of this memory location. Yeah. Let's just be sure that that does the same thing, and the output window is the same, right? So yet another way of, so we saw three different ways of copying that memory here. One is to use the copy command, that's a handy one, and the other was to use the subscript operator, or you could use pointer arithmetic here, right? So this is saying go this many integer chunks down the road from the starting place here, and then dereference what integers at that memory location, and assign to it the dereferenced value on the right there. All right. Okay. Black screen. Yeah, that was a while ago, right? I wasn't watching this chat window, but I'm assuming now it's good. All right. All right. So Oh, I notice I've eliminated myself from the which is probably just as well. But um, regard, the regarder. All right. Was there something else? Oh, I think he says do the same thing with vector. Right, where's that? Here? Yeah, there's part 13. Which we can type in here. Repeat 10 through 12 using a vector rather than array. Okay, so 10 was allocate an array of 10 ints. Okay, so this is going to be, shall I say this is part 13 here, just because things get a little confusing in here. So I'm going to say I've got a vector of ints v1, and there's 10 of them. And it's going to be these same guys here, right? Yeah. What? It doesn't like that? Oh. Does it want it like that? Yeah. Okay. So if you're being explicit, then you don't have to say, you know, how many there are. You can just spell them out explicitly, I guess. All right. Well, it seems to have done it. So now we've got our vector of 10 ints, powers of 2 up to 2 to the 9th. And what are we going to do next? Assign its address to a variable p1. I don't know as I need to do that. Assign its address to a variable. So the address of, okay, well, let's say I don't know, the address of a vector. So p1 is a pointer to an int, right? Can I say I'm going to give it the address of v1? No. It's not really saying why I can't do that. Oh, I'm looking at the, when I hover the cursor over the IntelliSense red line there, right? It's giving me a little pop-up window which doesn't show in OBS, and it says local variable p1 pointer to int, and it gives me a little search online thing. Do I want to search online? No. I think I just don't do this, right? And that's the whole idea of vectors, that it means you don't have to do that. So copy the values to a different vector. Okay, so I'm going to say vector of ints v2, and it's just going to be a copy of v1, which I could also do like with the curly braces, and maybe that speaks more to the sort of constructor. That's a copy constructor there. And so then for int I in v2, let's say, cout I followed by a space, and I guess I want to cout an end line here just to make sure we're on a new line when I do that. Maybe I should say the vector version. Okay, compile and run that, and it's no problem. We got our nice output, and yeah, you see the vector version. You don't have to fuss around with all the whole idea of the containers, that it handles that sort of nonsense for you. And you know, if we weren't learning about the vector, I'm going to have to repeat this as we go here this next couple of weeks. You know, we want to learn how vectors are made so we can make other similar kinds of things. But yeah, try to avoid pointers and use containers in algorithms, right? containers, iterators, and algorithms. Those three things, they work very well together in modern C++. There's all sorts of algorithms, and I guess we see that some of them are, some features are also in the numeric library, huh? All right. Okay, I think we're done with the drill. So let's go back to the Stroustrup text. And why do we need data structures with varying numbers of elements? Maybe we don't. I don't need them. I could. Oh, well, if I was going to be a computer scientist, I would want them. What kinds of storage do we have for a typical program? Well, you've got text, right? Where the actual text of your program is stored. The instructions in your C++ code, right? That's one type of memory. And we wouldn't want to mess with that. So it's sort of cordoned off to its own zone. Then you have static memory. Do we have to go back to here? Where is this? Yeah. So the code, static data, and what goes in static data? Well, your global variables, right? The free store, these are ones that we allocate and deallocate on purpose, and the stack storage or that's like, I guess, you know, they're trying to show you the free store is sort of in between these other two. I think that's true. Stack storage is for you know, local variables that you create by declaring like int x equals 5, right? That you're not allocating it on the free store. All right. And what is a dereference operator, and why do we need one? Well, it's symbolized by the asterisk, and it has to be an asterisk before a pointer variable, right? And it should be part of a right operand, right? So that you would, or a left operand, right? So it could be either left or right. So you can assign to it, or you can assign from it. Okay, memory addresses, we've talked about that. Okay, so yeah, go ahead and review all that. We've got exercises. All right, let's get to there. What is the output format of pointer values on your implementation? Hint, don't read the documentation. What? Oh, yeah, I keep coming across this question and wondering what the heck are they asking me? What is the output format of pointer values on your implementation? I think, oh, okay, so yeah, just what we did, right? So we saw that we had 32-bit memory addresses. So that's the format on my implementation. Yours may be different. Any Apple people out there with 64-bit? Yeah. How many bytes are there in an int? 4, typically. In a double, 8. In a bool? Well, yeah, the smallest addressable memory address is a byte. So even though a bool could be just 1 bit, in C++, the variable of type bool will have a size of 1, not 1/8. And they say don't use the size of except to verify your answer. Right. Write a function void to lower that replaces all uppercase characters in the C string S with their lowercase equivalents. Okay. That shouldn't take long. Let's do it. Yeah. What the heck? We are coming up on break time, so try to get a couple of exercises out of the way here. So, oh, we need to go remove this from the project and add new item PPP 17-exercise 3, and this is me doing oh, I should bring up the well, let me copy this from the text here and bring it over here to my code. PPP 17 exercise 3. Let's comment block here. Okay. Do not use any standard library functions. A C-style string is a zero-terminated array of characters, so if you find a character with the value 0, you are at the end. All right. So is this exercise? Yeah. And so we want a function void to lower. All right, let's just copy that, huh? What's its body going to look like? Well, so we're passing in a C string, right? A pointer to a character is a C string, and we want to walk through that string. The conditional then can be, so we can say something like for int I equals 0, that's the initializer, right? And then the conditional will be simply this, right? And we could say not equal to the null character. That's not to be confused with the null pointer, okay? That's the null character. But the null character is as a Boolean is interpreted as false. So we could just say the conditional is s of I. So any value other than the null character will be true. Do we need to update I? Yeah. So I guess we'll say what if it's an uppercase. How do we know if it's uppercase? If well. S of I is greater than or equal to, I guess, uppercase A, and it's less than or equal to an uppercase Z, then S of I, we're going to subtract A. Is that what we're going to do? Oh no. That was dumb. We're going to add 32. Is that going to work? Right there, 32, that's like 2 to the 5th is 32, right? So it's a single bit that gets set to change from uppercase to lowercase, right? And so ASCII for capital A is 65, ASCII for lowercase a is 97. They differ by 32, right? All right. So let's say that's good then. All right. So we want to be able to print the array. So which we have a little print function. Print C string, and it's going to take a character pointer S, and it's going to say, you know, while S is not the null character. Cout s. Do we have to do it that way, or does that even work? Oh, yeah, I guess we should have an int I equals 0 here, huh? Oh, and then should we have a post increment on that? I know that's kind of sneaky, huh? Oh, we didn't include any libraries. Include IOStream. Using namespace, why not, right? Okay, so here's main. Cout enter string. Okay, and here's a variable type string. Oh, do we need the string library then? Maybe, huh? And enter a string. So we're gonna get line. We're gonna do get line, right? And so get line. Does it have like a space or an underscore? Get line. Nobody knows get line. Get line. I seem to have a hard time. So can I do like a while get line? That's not it, huh? Who remembers you have a capital I for include? I do. So true. Thank you. It's my habit to capitalize the first letter in a sentence. Yeah, it's ingrained. Oh, and get line works. Oh, so yeah, it's because I think get line is in the string library, right? And I hadn't. That would explain that. Okay, so while I can do that, I want to. How about print C string of to lower of s? Oh, s dot C string, right? Because I want to convert it to a C. That's kind of cheesy, huh? I don't know. Oh, I thought it was called to lower. It is called to lower. What's the problem here? Argument of type void is incompatible with a parameter. Oh. Oh. Okay. I think okay, so rather than converting this to a C string like that, I'm going to pass it a pointer to a character, right? So that doesn't like that. Oh, so a pointer to a character. Is the address of a character, right? And so s of 0 is the first character in that string, and I'm passing its address what's the problem? Oh, I think, is there like a, okay, argument of type void is incompatible with the parameter of type character pointer. Oh, yeah, see, this is returning void, right? What do we want to return? Yeah. Oh, I see. So we just call to lower on. Okay, so we're going to make this a separate function call. So first convert it to lower, and that's okay, right? And then print it separately, right? So we can't take the output of that, but we can do this, I think. No? Print screen takes, so if this takes a pointer to character, and that works. Oh, I think I see the semicolon. Yeah, okay, I think we're happy now. Shoot. Should we put in a new line or something? I think, do we need a new line? Let's see, maybe. So here's the output window. And hello world. Capital W world? I guess that is a capital W. There it is with a lowercase. And so now I'm going to say, Right? Okay. Well, that was easy. All right. And it looks like it's time for a break. Any questions before the break? And yeah, thanks for pointing. I would have been still wondering, why is it not allowing me to use getLine? Because I always like, which getLine is it? Does it have an underscore? Does it belong to cin, or does it take cin? And there's a lot of varieties of getLine. All right. Well, seeing no questions. And this is the kind of thing where I can make a quiz out of this, asking things, or the problem with the fill in the blank, if you to choose the right words. The thing is, I can say use this or this or this or this, and then I can try to cover all the bases. But students so often surprise me with thinking of things that I wouldn't have thought of, but are still correct or whatever. All right, well, let's take a pause and see you in 10. Yeah. All right, how's everybody doing? Did I ask this group if anybody's in like a science class? Chemistry? One of those classes with a lab, right? Physics has lab, right? Just kind of curious. I saw that people were experimenting with this thing called Labster, which I think is a chimera of lobster and hamster. I can imagine a strange looking animal there. And that it was great, except it was all wrong. Which reminded me of the old computer science aphorism. If it doesn't have to be correct, I can make it as fast as you like. All right. So I guess one thing I'm wondering about is here I'm passing it the address. I mean, this is, why not just pass it S, right? So notice it's got the little IntelliSense there then saying, oh no, you can't do that. Why not? Well, if it were a C string, you could, right? Because the name of the array, C string is an array of characters, and the name of the array is the address of the first character in that array. And that's fine. But for a string object, not a C string, but a std string, it's got other wrappings around it, and so you don't get direct access to the memory location through its name. But what if I were to pass it C string like I was trying to do before with that? Yeah. It doesn't seem to like that either, huh? What does it say now? Same thing? It's expecting a pointer to a character or a memory location. And if you just convert it to a C string, I guess that doesn't quite give you the memory location either. So to get the memory location, you have to say, look, I've got an array associated with the stood string, and the first character is indexed by S of 0, and I can get the address of that first character like so, right? All right. And if it's in that certain range, okay, well, let's just say we're good. We're good to go there. All right. So what's next? Write a function that copies a C-style string into memory it allocates on the free store. Do not use any of the standard library functions. Right, there are library functions to do these things, right? String dupe is what I think that's saying there, right? String dupe. Duplicate a string. All right. Sure. It should be fairly quick, huh? So I'm going to exclude this from the project. Oh, did I click on the wrong thing? Oh, yeah, I did. Okay. And save that? Okay. Oh, yeah, here, huh? And then add new item. It's going to be PPP17-exercise 404. Okay. Copy. Okay, write a function copies a C-style string, locates on the store. Do not use any of the standard. So there are standard library functions to do. I said that before, didn't I? Let's see. So shall we? Let's just include standard library facilities. Make that quick. And so string copy. Okay, so let's just copy this string. Speaking of copying, gives the footprint for this thing. Oh, maybe I should be using more proper practice, right? So I'll have our main here, and then the definition after the prototype, right? Okay. So how are we going to do this? I think we have to know how big that an array doesn't know how big it is, right? And we need to know how big it is. So the first thing we got to do is measure its size, right? So I'm going to say, okay, I've got a counter, and it's going to be 0 to start out with, and then I'm going to say while s of I'll do a post increment here. Is that too clever? That's then going to do it, right? Then when we're done with that, n is going to be the length of the string. Yeah? right? So this while loop doesn't have any body. It just keeps doing the conditional, and as part of the conditional, it increments n. Oh, you could, sorry. There we go. You got to remind me of that occasionally. Thank you. So we've got, right, so this is what I was saying, that we've got, here's our function, string dupe with its prototype here. We haven't defined main yet. And the first thing we need to do when we get a C-style string, which is an array of characters, an array doesn't know how big it is, right? That's one of the nice things about a std string, is you can say, tell me its size. This we don't have that, so well, here's a way of doing it, right? All right, so then I'm going to say, whoops, what happened? I'm going to make a new string. What am I going to do? Yeah. Okay, so I'm going to allocate memory. Right, so they want me to allocate memory on the for an array of characters on the free store, right? Yeah. So should we call this duplicate? And it's going to be equal to the memory address of the first of an array of characters with how many characters? Well, actually we need one more than n, right? Why? Well, because we're going to have to put our own capstone at the end of this thing, right? So now we've allocated memory for this thing. Now we can just copy into it. Okay, so I'm going to say for int I equals 0, I less than n, increment I, and say that the duplicate of I is what you get when you, well, can we, I think we just use the index operator, right? So we can just say s of I. And then we need to put the capstone at the end, right? So we can say duplicate of n. Yeah, that's going to be the n plus first character, actually, right? The first one is 0. And we need to put our null character there. Okay. Well, let's now put main together, right? So in main, we're going to need a string s, which we can get from the user with a get line, maybe. So how do we want to do this? So what are the instructions again? Write a function that copies a C-style. Okay, so that's not, S is not a C-style string, right? So we want to get a C-style string. Okay, let's just do, and let's make it an infinite loop. So I'm going to say while cn, so we get a string, and how shall we say we're done? How about s is not equal to the empty string? Okay, then it says not to use any of the standard library functions. I'm tempted to use string copy here, right? That's a standard library function though, right? Do not use any standard library functions. Oh, sorry, I want to. Okay, so we could just, um, um, so we're going to have a local pointer to a character. Oh yeah, so we need another C style string here, right? So okay, so that's a pointer to a character, right? C string, and we haven't allocated that on the free store. Should we do that, or do we care? Yeah. Okay, so this is going to be equal to new character array of s dot size plus 1 for that null character. Okay, so we're allocating memory on. Now we're responsible for that. It's like, in high school or something, they make you carry around a baby for like a week or something. I should make you carry around a free store allocated memory for a week, so you realize your responsibilities in this world. Oh, are we good? Yeah, we're good now, right? Yeah, I was looking at. I'm a little slow on the chat today. Okay, so what are we going to do now? Oh, we're going to. Okay, so we're not going to use the we could use string copy, which is a standard library function, right? But that would be wrong, not following instructions. So we're going to say for int I. So I'm just copying the string into our string, and then I'm going to call it string copy. So how do you get the string as a C string to call string copy on it? Well, you have to get a std style string. I mean, there's probably a better way of doing this. Okay, I'm making this too long. Let's just do it one way or another. So for int I equals 0, I less than s dot size, which is a standard library function. Is that wrong? Oh. So, all right, let's just do this way. Maybe I'll get dinged for. So I'm going to say C string of I is equal to S of I. I'm just making a copy of each character by character, and then I'm going to say C string of S dot size. That's the n plus first character. Oh, yeah. Right, which is good. I think that's what we want, and that's going to be equal to. So I'm sort of doing this twice, aren't I? Okay, but now I'm going to call string dupe, and okay. So first I should free this memory, right? Oh, you know what? I could have. Oh, yeah. So I am doing overkill here. Sorry. I'm okay. I'm not going to erase this. But yeah, I was having some angst about it, and that was well-founded angst. Because well, here's what I'm going to do. I'm going to say yeah. So I've got my string. Right, so the reason I used the string here was so I could get it easily using cin, right? It's not that easy to get a C string from the console, but it's pretty easy to get a std string from the console. So I got the std string. I'm now going to pass the address of its first character as the argument to string copy, and then return that to all right, so I don't need to allocate memory here. Yeah, so I've kind of messed this up, haven't I? So I'm going to say S string or C string equals the output of string dupe, right? And I'm going to give it the address of the first character in the string that was passed in, right? And then should we verify that it is what we think it is? Do we have a print character for this? Okay, so for int I equals, I have to type this all again, huh? I less, or I'm just going to say C string. So this is the conditional for looping, right? And oh, yeah, and I did that in the function, right? I put a capstone at the end. And I'm going to say cout C string of I. Okay, so let's test it. No, it's got an error. String dupe. What does it say about string dupe? The POSIX name for this item is deprecated. Instead, use the conformant name string dupe. What? The POSIX name for this item? Oh. How about string duple? Yeah? You happier now? That was a ridiculous message. Oh. String duple must return a value. All right. Right. So we want to return a pointer to a character, right? What shall we return? I guess duplicate? Okay, so now it's happy. We can go to the output window and we can type in Froggy Wint Corton. Froggy Wint a Corton. Boggy Boo. Can we put in spaces? Oh, it ignores the spaces. Why is that? Oh, it got, so it actually called string dupe 3 times, right? Because we're using cin to get the string, and we could instead do a get line like so. Yeah. So now if I say, oh, here's the output window. Foggy do. It says foggy do. All right, so it's just duplicating the string. Oh, and then when I press enter now, it says, oh, that's an empty string, and that's the condition for quitting. So I guess if I was going to be nice about this, I would put an end line here. Oh, yeah, let me just compile and run that again. So here's la 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 la. Oh, wow. Oh, it's printing out each one separately. Let me show you where did I put the end line? Oh, yeah, here, huh? Yeah, I don't want to do that on each character. I want to do it here. Oh. Missing semicolon? Oh yeah, sure enough. Okay, so let's see, can I just get a whole bunch of text here and paste it in? So I'm going to copy that to the clipboard and paste it in. Oh, I guess there was an empty string in there somewhere, right? Huh. Oh, that's offensive. Where is that coming from? I don't know. Let's see, the comedian, it's Donald Knuth, huh? Oh, well, let's just grab a chunk of that without any empty spaces. And try that. So I actually have something in mind here, which is that I'm not done. How big is your beard? Your board. I don't have a beard. I don't have a board either. I think I must have gotten the wrong code. Okay, F5. Okay. So what is going on here? Okay, yeah, let me go back to the code window so you can see. Let me get rid of me. So, all right, so if I'm going to continue to do what I was doing, which was just pasting output into the window. You see what's happening in the process memory there on the right? We've got, what is that called? What is that that does something like that? That's a memory leak. All right, you see? Oh, that was odd. Look at that. It dropped suddenly. That's the compiler trying to protect me from myself. But no, I insist on memory leaking. I must memory leak. There. More memory leak. I'm going up and up and up and up. I'm just keep pressing entering with a large thing to copy. So how do we get rid of that? Well, somebody's got to free up that memory. Who should free it up, do you suppose? Should it be the caller or the callee? Inquiring minds would like to know. Well, I suppose the callee could do it, or, you know, let's try the callee, right? So I'm going to put in, that's the one who's called, right? So can I free up the memory in here? So here, this is the callee, right? So what would I do? Would I delete delete S? That's the input, right? Let's see, if I delete S, I'm going to be okay, because and S is an array, right? So I'm going to say delete S. Let's see if that doesn't fix the memory leak. So F5, everything is happy. I'm doing the same thing I did before, but now I've triggered a breakpoint right there. It doesn't like that. Maybe it's something to do with my input. Doesn't give you much information when it throws an exception like that, so it's hard to know what exactly went wrong. But maybe should we try the caller, freeze the memory? So I didn't get so back to the output here. You can see it didn't get all of that input. Where it got as far as but only the. I see. So it's doing line by line. So every time it gets a line, if it sees a new line, that means it's going to copy that line, right? So it copied the first line, but it didn't copy the second line. Is that because I need to... well, I think it's because I deleted it, right? Oh. Huh. So it became the empty... So it didn't throw an error. It just became the empty string because it was deleted, maybe? I don't know. Okay. So let me close that and go back to the code. So, okay, so I'm not going to delete it here. I am going to delete it in main, right? Just after, where? Here? And what am I going to delete in main? I guess C string? Okay. Let's see if that'll work. Okay, we're getting some output here. And this, yeah, now it's copying everything. Analyze a NIM-like game. Didn't we start with that? Yeah. So each line is getting copied once, so line by line. And so the question becomes, are we getting a memory leak? So let's go back to our Visual Studio window and see as I keep pressing enter here. Yeah, I see that in process memory, I'm no longer leaking memory, right? You can see it's a constant 899 or 898 there. So that's fixed the memory leak. Okay, and we did it by having the caller handle it. All right. If I just press enter, then it'll copy the, yeah, so it's waiting for me to copy that last thing, right? Oh, it's funny, the memory went down, huh? Oh, you can't see the output, but now I'm entering again. I'm not sure why the memory got freed up there, but it did. Or maybe it just got rescaled or something, right? Who knows? But yeah, I'm continuing to press enter and copying over all those lines and not leaking any memory. All right, sorry, that took too long. I know, I said it wasn't going to take that long. Shall we inquire about the Nbody problem since we said we would? All right. Oh God, but that puts me in a whole different frame of mind. So where is that? Is that in here? Maybe. I don't think so, though. Is it in here? Oh, we don't have that open. Okay. I gotta remember where it is. Okay, that shouldn't be too hard. Okay. And Okay, so I'm going to open a new instance of Visual Studio. And I think it's, yeah, it's going to be in here, huh? Okay, so I just have to find something to associate with that. How about this one? And I think it's that one then. Okay. So maybe I should ask, how's it all going on this? Is it reasonably doable? Yep. Okay. Yeah, I look forward to seeing that. But I have to finish reading the pool stuff first, and then before I do that, I want to get part 2 of the midterm out there, so you can watch for that. But let's see, what if we just... Well, we have to do a little pencil and paper work. I haven't done this yet, right? So should we do it in the comments up here? Yeah, I got a comment for Caesar because I started with his code to do this. Caesar in the house? We'll take a look here. Woo is here. How are things in Los Angeles? You still there? All right. Created the key to cryptography quiz. No, I guess, yeah, that's another one that I have to... Okay. Yeah. I kind of take the Obama approach to matters of politics and coping with, don't look back, just look forward. Yeah. Torture, war crimes, that was all in the past. So was the cryptography, key to cryptography. Yeah, it's ancient history. No, everything will be dealt with in due course. Sometimes at the end of this course, it takes me a long time to process everybody's work, and so there's a little bit of a delay in getting out the grades, because I will read all your work. Yeah. And all those war criminals are going to jail. Yes, they are. And other nefarious actors. So, yeah, that's the Nbody stuff. And so the question here, shall I run this? What does it do? I think it prints out to the console, and also it prints out both to the console and to these two F streams, right? The various data you need to plot the course of these things. So let's assume that that's just correct, right? So then let's go to the solutions to the last one, which are here somewhere. Let's go to then our browser. And I don't know, here. Okay. Part 2 actually contains the solutions to part 1, right? And that involved this center of mass computation, right? Which you can see here. Okay, so where can I write this? Let's see. Does this paint thing refer to this? No, it doesn't. Okay. I can make it do so, though. So I'm going to say properties. Then I'm going to say somewhere in here, my list of applications that are running is the GIMP. There it is. And okay. So I'm associating GIMP with that, and then it should appear before that, right? So, yeah. so I can write on the screen. Okay, I should probably choose a different color, something darker maybe in here, and okay. So now, yeah, that's a little bit more readable. Okay, so what I'm thinking is, you've got a number line here, and here's the sun, right? Let's say that's over here. And then here's the Earth. I'm just going to put an E for Earth. And let's say, which is the moon to the left or the right? They're all going to be collinear to start out with, right? Because that just simplifies things. So we could put moon over here. And then we want to find the center of mass of this system, which is going to be a lot closer to the sun, right? So this is going to be our 0. And we would like to know what these relative distances are. What is the distance from the sun to the Earth? That's going to go there, right? And for that, we're going to do a little sleuthing. Let me turn off this paint thing briefly. And what, okay, I think that's fine. I can use this. We're going to say Earth, Sun, distance, and I think we want that in meters, right? So here it is in miles because we're Americans. That's the way we like things. So it says it in miles. So here's space.com. Maybe they're a little bit more scientific about things. Oh, look at that sun. Yeah. It's an amazing thing. So I got to say, stellar astronomy. I studied a little bit of stellar astronomy. I took actually a graduate level course in stellar. It was a seminar. It's great. I could study that stuff all day long. But let's get the information we need here. Modern instruments can come within a few meters of exactly determining the distance of nearly 150 million kilometers. Yeah. Okay, so nearly. Can't we do better than that? Well, I guess it varies. Is that an average number or something? It doesn't look very scientific. All right, let's go back. Here's a question for you. Why is it that we depend on the Russians to get into space? Oh yeah, Elon Musk. Okay, don't get me started. I mean, manned vehicles. Well, yeah, Elon Musk again, right? But that guy is a clown. You could go ahead and like Elon Musk. He can be your hero. That's fine. Don't mind me. I just have opinions about things because I'm an old crotchety fart. So when is Earth closest? Measuring distances? NASA. How about, yeah, NASA ought to have it. Distance from, okay. Yeah, so this looks like a pretty good number here, right? So that's kilometers, which are thousands of meters. I think we want actually meters, don't we? We're in the Newton meter. Oh, do we want kilometers actually, right? Well, let's just copy that. Oh, well, 1496. Okay. So I can go back to where am I? I was here. Yeah, okay. And then I'm going to turn on my... Oh, I got to go all the way over here. Okay. So this is 1496 0 0 0. Should I just say 1.496 E? So that was millions, and so it'll be times 1,000, right? So that's billions. 149 billion. A billion is, so that's going to be 11, I think. Oh, you can't read that very well, huh? Can I move this? What can I do? I think I can go over here, grab this window, and move it down like that, huh? Okay. Oh. Huh. I don't see this decimal point here. Is that clearly a decimal point now? Yeah. And E11, huh? And so then we already had the Earth Moon distance. What was that? That computation is in here somewhere, huh? That's E8. So that's, yeah, so the distance to the sun is about 1,000 times the distance to the moon. Does that seem reasonable? I guess so. And these are meters, right? Okay. So you're going to have to, well, I guess we're kind of running out of time here, so we're not going to be able to get very far with this. How about the speed of the Earth relative to the sun? Right, that's going to be another computation you're going to have to do. So you're going to have, oh, so we also have this Earth Moon. So we have the relative distances between these things, and so you can just substitute down to a single variable, right, to get one unknown and then compute the rest of them. It's like you can have like a system of equations, right? But then how would this computation here go, right, for the period of orbit of the Earth? Well, 364.24 days. Now here they've got it down to a much more precise number, and I found that it was actually necessary to have quite a bit of precision here in order for it to get a stable orbit, right? And then we'll have the speed of the Earth relative to the sun. Oh, relative to the center of mass, right? So you're going to have to rethink this whole computation with, and not only that, you're going to have to do it with Mars and Venus. All right, that's another thing to consider over the long weekend of locked downedness. So what else do you have to do? Well, let me ask if there are any questions about anything, since we're just about at our end here. That was a good question about the. Thanks for the reminder about the cryptography quiz. Yeah. Okay. Well then, I feel like I'm a little bit warmed up here and ready to get this rolling. And I don't know. Should we research? Let's see. Should we go back and then search here? The length of sidereal year. Is that what we want? In seconds. And let's turn off this scribbling. Sidereal year. Convert your sidereal year to seconds. Oh, well, this is a little applet for that, huh? but okay, looks like they got it here, huh? Quick conversion chart for sidereal years to second. 1 sidereal year to seconds. Ah, yeah, looks like that's it, huh? Shall I copy and paste that to my code? Where can I put this? How about up here? Should probably make a new version of this, but seconds per sidereal. Sidereal mean relative to the stars, right? Well, you know, I appreciate that some of you have been putting in good time on this. I know you got other classes. Really applaud everything you're doing. I think it's great. And gives me great confidence in the future. So I guess with that, I'll take up from here and bid you a pleasant evening. All right, I sent projects through the email. Okay, great. Yeah, right. Saw that. Okay, take care and see you later. I guess I'll, what do I do here? Okay.